Okay, so in this homework, I'm going to go over the solutions to derivatives with trigonometric functions. So by now we have to know our list up here that the derivative of sine is cosine of u times u prime. The derivative of cosine is negative sine of u times u prime. The derivative of tangent is secant squared u times u prime. The derivative of cosecant is negative cosecant u cotangent u times u prime. The derivative of secant is secant u tangent u times u prime. And cotangent u is negative cosecant squared times u prime. Just got to keep in mind that the derivative of a c function is a negative answer. The derivative of a c function is a negative answer. All right, so let me take you through these. So again, we're going to ask ourselves the same question. Do we have a quotient? No. Do we have a product? No. Do we have a function within a function? And the answer is yes. My outside function is sine. My inside function is this. So the derivative of sine is cosine. Repeat the inside, but the derivative of the inside, the derivative of x to the 1/2, is 1/2 x to the negative 1/2 by my power rule. Nothing else. Remember this, that this is never multiplied by that. This would just go in front of the cosine function. And number 2, no quotient, no product, function within a function. Box the outside, circle the inside. The derivative of cosine is negative sine. Repeat the inside, but the derivative of that inside is a power rule. Drop down the 2/3, repeat the x, and decrease it by 1. In number 3, the derivative of tangent, it's an outside function, that's all we got, is secant squared. But repeat the inside, and the derivative of that inside is 2x. Do we have a quotient? No quotient, no product, function within a function. The derivative of secant is secant, a little longer to rewrite, tangent. It's secant u tangent u. But the derivative of that inside is just -2. Again, guys, this -2 is not multiplied by those arguments. The -2 would just be in front. The derivative of cosecant is negative cosecant u, cotangent u. So we just rewrite that x to the 1/3 there twice. But the derivative of that inside is a power rule. So it's 1/3 x to the -2/3. We have no product, no quotient, no product. We got a function within a function. The derivative of cotangent is negative cosecant squared. Repeat the inside, but the derivative of this inside is I'm going to make this x to the negative first. No quotient rule, because I can rewrite that as x to the negative first, and now do a power rule, negative x to the negative second. Here, we don't have a quotient, but we have a product. So we've got to do a product rule. So that's going to be the first function, which is sine of 2x, times the derivative of the second, which is negative sine of 2x times 2. And that's not subtraction, that's times a negative. Plus the second, which is cosine of 2x, times the derivative of the first, which is cosine of 2x times 2. And that does clean up a little bit. So I'm going to clean that up to be -2 sine squared of 2x plus 2 cosine squared of 2x. And that actually cleans up to be a trig identity. In number 8, we don't have a quotient, we don't have a product, but we've got a function within a function. And I got kind of a function within a function yet. So I'm going to remove this power to the outside. So my outside functions is power, while my inside is all of this. So all I just did was take that power to the outside. How do you differentiate a power? You drop down the power, repeat the inside, decrease the power by 1, and times it by the derivative of the inside. The derivative of the inside would be cosine, repeat the inside, x squared plus x, times it by the derivative of the inside, which is 2x plus 1. Here, I have no quotient, no product, but I got a function within a function within a function. I'm going to rewrite the radical to the 1/2 power, and my outside function's the box, it's the power. And the inside is that. So how do you differentiate a power function? Well, you drop down the power, you repeat the inside, if I can copy that right. Decrease the power by 1, and then the derivative of the inside, and that's just 0, the derivative of sine is cosine of 3x times 3. And number 10, finally, I got a quotient. I got to do a quotient rule. I don't know if I have enough room here, but I'm going to do my best. So it's going to be the bottom times the derivative of the top, which would be plus cosine of x, minus the top times the derivative of the bottom, which is just negative sine, all over the bottom squared. And this cleans up, I think, pretty nicely. Some pretty cool trig here. So I'm going to distribute through. Where am I going to fit this over here, I guess, here? So this will be cosine of x plus cosine squared of x plus sine squared of x, all over 1 plus cosine of x squared. But sine squared plus cosine squared is 1. So this cleans up to be 1 plus that. So it's 1 plus cosine of x divided by 1 plus cosine of x squared. And lo and behold, one of these divides out with one of these, and my answer is 1 over 1 plus cosine of x. In number 11, do we have a quotient? Yes. And can we use algebra first or a rewrite first or a quotient rule? And the answer is we can rewrite this because I'm just dividing by this monomial down here, this singular trig function. So I can rewrite this as sine over cosine is the tangent of 2x, and cosine 2x over cosine 2x is 1. So all I just did was rewrite that. And it's a lot easier, I think you can see, than doing some quotient rule and cleaning it up. So the derivative of tangent is secant squared of 2x times 2. And the derivative of 1 is just 0. This is a pretty neat one. We got a function within a function within a function again. So there's no quotient, no product, but we've got the chain rule a couple of times here. So you start with the outside function. When you're differentiating by a function within a function, box the outside, circle the inside. The derivative of that, I'm going to take this here, is cosine. You repeat the inside, of course, but the derivative of the inside is another trigonometric function. So the derivative of cosine, if I can fit it here, is negative sine of 2x times 2. And these are some very important questions. Number 13, a tangent line. You cannot avoid those questions. Good trigonometry. So number 13, a tangent line triggers a slope, which is my derivative, and a point. And my point is pi over 4. My derivative is going to be equal to this. The derivative is just an outside function. So the derivative of secant is secant tangent times 3. I've got to evaluate that at pi over 4, and we cannot avoid this trig. So it's secant 3 pi over 4, tangent 3 pi over 4 times 3. All right, so here's what I do. Draw 3 pi over 4. Here we go. And the reference angle is pi over 4. When that's your reference angle, your sides are 1, 1, and root 2, but negative in that quadrant. So the secant is r, which is root 2, over x, which is negative 1. And the tangent is the y over the x, or the negative 1, times 3. And I think that cleans up generously to be 3 root of 2. Pi over 4 comes from plugging this in here. So the secant of 3 pi over 4, again, secant's the reciprocal of cosine. So you could think of cosine as negative 1 over root 2. Secant is its reciprocal, which would be negative root 2. So this is not too bad of one, actually. So the tangent line is going to be y minus my y coordinate over x minus my x coordinate equals my slope, which is 3 root of 2. And what am I going to have here? So this is going to imply y plus root of 2 equals 3 root of 2 times x minus pi over 4. I'm just going to add that, or subtract, sorry, that root of 2. And there's a pretty decent line. Man, that took up a lot of space. That's 13. All right, 14, another important one. Find just the slope of the tangent line. So just the slope is the derivative. So the tangent line, the slope of the tangent line is the derivative at that point. So the derivative of sine is cosine. Repeat the inside times it by 2. The derivative of cosine is negative sine times that positive is a positive sign. Ooh, and that's a 3x if I see it correctly, right? So that's a 3x times 3, though, at x equals pi. So all I have to do is just replace x with pi. So this is going to be some good trig. There's no calculus now, it's just trig. And the cosine of 2 pi puts me here. The x coordinate's 1 times 2 is 2. And the sine of 3 pi, that's 2 pi, 1 pi makes 3 pi. The coordinates there for sine is 0, and 2 plus 0 is 2, so my slope is 2. No line to figure out. So a lot less work. And number 15, the tangent line. Again, let me see you write what that triggers. A slope and a point. The point is at x equals 0. The slope of the tangent comes from the derivative. And the derivative of sine is cosine. Repeat the inside times it by 2. But the derivative of cosine is minus sine of x over 2 times 1/2, because that's the same thing as 1/2 x. Sometimes that, like students think that, you have to do a quotient rule. It's just 1/2 x, and its derivative is 1/2. I'm just going to replace x with 0 now. And this is going to produce the cosine of 0. I can actually do it right here, I guess, times it by 2. And the sine of 0 is 0 times 1/2 is 0. The cosine of 0 is 1 times 2 is 2. So that's 2. And cosine of 0, oh, geez, I have to put 0 into here yet for the y coordinate. So the sine of 0 is 0. So this is going to be the sine of 0 plus the cosine of 0 over 2. So that's just 0, and that's just 1. So 0 plus 1 is 1. So my ordered pair is 0, 1. So I've got to finish it out. So it's y minus the y coordinate over x minus the x coordinate equals my slope. The y, the x, and my slope. I'm going to cross multiply and have the 1, and there it is. And that concludes the solutions to homework number 17 of our trigonometric functions.